All righty, welcome back. Here we go. We're going to do 3.2 and a little bit of 3.6. Actually, the fun part's 3.6.
Yep.
We got a half-life problem.
Okay, so we have this radioactive substance. Mr. Leckie, what's half-life?
It's a cool video game.
Oh, great. Why am I not surprised?
Half-life is the amount of time
Yes.
that it takes for half of the substance to decay or to disappear.
So if I jump out of the screen in 1 second, our half-life would be 1 second?
I guess.
Because of half of us?
Is it? I think there's less than half of us if one of us jumps out of the screen. Okay.
Depends on if it's me or you.
The half-life is 14 days.
Okay, well, 14 days. Our time is normally our exponent.
Okay, so what do we start with in this problem?
We started with 10 grams.
So we got y equals 10, but my problem is I don't know what that growth or decay factor, but I know it's going to be decay.
Right.
But I don't know what it is. I'm going to just label it b to the x power.
Okay.
And I got to find b now.
All right. But don't we also know that x is really 14 days?
Yeah, when x is 14 days, we know what, though?
Oh, then we know we have half the substance. So when x is 14, y is actually 5.
Because that is half of what we started. That's what half-life does. So we're going to solve for the b value in this problem because it's not given to us.
Okay.
All right. So putting all that together, we have 5 equals 10 times b to the 14th power.
Correct. Divide by 10.
All right. Good idea. So 5 divided by 10 is amazingly 1/2.
Oh, that looks familiar.
All right.
And then we have to undo an exponent of 14. Please don't say divide by 14.
I had someone say it was the 14th square root.
Kinda. How about the 14th root?
Oh, all right, 14th root. But that's easier to write as a fractional exponent if we raise both sides to the 1/14th power.
When you raise a power to a power, you multiply, and 14 times 1/14 is 1.
Yay, so that's just b.
Great.
And this side is just 1/2 to the 1/14th power, and without a calculator, I'm going to leave it that way. Is that okay?
Okay, but that's our base.
That's our base.
So we can write our equation now with an x and a y.
So we have y equals 10, because that's what we started with.
Yes.
Times 1/2 to the 1/14th power.
Yes.
Raised to the x.
Perfect.
Can we clean that up just a little?
And we could put the 1/14th out by the x. Because when you raise power to power, you multiply. I think I just said that.
And for those of you that took chemistry or remember chemistry or don't twitch when you hear the word chemistry, that is a half-life formula that you could memorize.
Right.
Because we started with 10, and instead of having to do all this work, we just take half of it every 14 days, so we don't want the exponent to be a 1 until we reach 14 days, and we do that by doing x over 14.
Great.
And so we could just memorize that and go straight to it.
Okay. So now what we want to do is apply this. When will there be less than 1 gram remaining? So
1
again,
gram.
We're going to do the same thing we did on the last problem.
Is that a time or is that an x or a y value?
1 gram is a y value.
That's a y value. So we're going to go 1 equals 10 times 1/2 to the x over 14th power.
So again, we could type our y1 as a 1, and we could type our y2 as that other big mess. Now be careful when you do that because your exponent needs to have parentheses around the 1 over 14.
If you have a new 84, it would write it as in the little exponent world area.
Right.
But if you don't, you need to make sure that this looks kind of like this. That would be 10 times 1/2 raised to the x over 14, where the x divided by 14 is in parentheses, or it doesn't work.
It doesn't work.
All right,
so
solve the same way as the last one?
Exactly. We're going to graph it. You're going to have an exponential decay function working, and then you're going to have a line for 1. And the x value that you get is 46.507 days.
47? What'd you say?
46.
46.507
days.
507 days. I'm a little slow.
But because the question says when will there be less than that amount remaining.
Wow. So is that going to be?
It's not one answer that's our answer. There's an interval that's our answer.
So if we were to think about this graph here would be a decay function that started at 10, go like this, and then 1 would be down here.
Yes.
And as this goes lower, because the board sucks, that
the
intersection point
is 46.507.
So we actually want this to be greater than
Correct.
46.507 days.
Yes. You got it right now.
Or equal to. Is that okay?
That's okay.
All right, high
Next.
five. All right, now exponential functions grow all the time. They grow without bound. They just keep going and going and going forever. That's not really realistic. Okay, if your population of a city cannot grow exponentially forever, there's only so much room in the city, people will just be stacked on top of each other. Okay, so we have this idea that if you have a container or a city or a place that things are growing exponentially, that can happen for a while, but eventually it's going to slow down because there's not enough room for everything. And so we have what we call logistic functions. And again, we mentioned these in chapter 1. All you really had to do in chapter 1 was match them with a pretty picture. Logistic functions are going to be of this form: f of x equals c divided by 1 plus a times e to the negative bx. Hopefully you can see that. Or f of x is going to equal c over 1 plus a times b to the x. And you might be wondering why there's two different ones. We're going to go with this continuous growth concept and using the e value for our functions that we're going to deal with, and not so much the other ones. But you could use either one in the context of a problem if once you get there. But c is that limiting growth. That idea that there's only so much you can do in growing wise. You're going to reach a limit. And what it looks like when you graph this thing is you have the x and y axis here. We had a horizontal asymptote at y equals 0, if you remember chapter 1. But what we're saying is we have this limiting growth at y equals c also. That's supposed to be a c, not another 0. How about a c? There we go. And we're going to find the y-intercept at some point, just like we did as an exponential function. And this function is going to start off growing exponentially, and then it's eventually going to level off and find that other horizontal asymptote as its limiting value. Okay, so you have two horizontal asymptotes. We're going to find the y-intercept and answer some questions and see how this works. All right, well, here's an example of a logistic function. Notice our function here fits our idea of f of x equals c over 1 plus a times b, e to the negative bx. That's the ugliest looking function ever. So pretend I never wrote it. Look up at the top of your paper for the last example and you can write it that way. But it looks like one of those, okay? Let's just get into this. What was the initial number? Now, initial means the amount of people, there were a number of the students were infected with, what is that, the flu after T days at Springfield High School, modeled by this function, okay? So the initial number of infected students. Now, initial means the beginning, and help you out, that means time is 0. So you simply plug in 0 for t, and you work it out. 1600 over 1 plus 99 e to the negative 0.4 times 0. Whew. Well, there's a funny thing about 0 exponents. Negative 0.4 times 0 is still 0. So e is raised to the 0 power. Well, e to the 0 is 1. Anything to the 0 power other than 0 is 1. So that becomes, on the bottom, 1 plus 99 times 1, which is just 100. And 1600 over 100 is 16. Therefore, there were 16 students infected at the very beginning. And if you look at this picture, this wonderful graph, ask yourself, does that kind of look like 16 at the beginning? Well, you're counting by hundreds. That's a pretty darn low number. And you can't argue that it's not. Let's put it that way. All right, after 5 days, how many students will be infected? Well, the same thing occurs. Pay attention. 5 is what? Days. T is days. So make T 5, and you just plug it in. Okay, piece of cake. 1600 over 1 plus 99e to the negative 0.4 times 5. Now, what you need to do is take out your calculator right now and type all that in, press pause, and see if you can get the following number. This should come out to 111.125055, so that we don't have parts of students walking around infected by the flu. We'll say approximately 111 students are infected after 5 days. But part of this is you making sure you can type this in correctly. I'm not going to take the video time to push buttons on the calculator right now, but make sure you can. And if you're having trouble, first thing you do when you get to class tomorrow is you come in and you talk to me about how do you punch that in, okay? All right, now, what is the maximum number of students? Maximum number of students is up here. You can even look at it on the graph. There looks like there's a horizontal asymptote for this logistic function. Just spread it right across. And since we're counting by hundreds, that's at 1600. That looks to be our maximum number of students. Now, you don't need the graph. You actually only need the equation. We get the limiting value. That was our C value in our equation. Our limited growth, that is 1600. Okay, example 3.
All right.
Now, we have a logistic problem here.
We do.
Last lesson, we kind of gave you the logistic problem and asked you to answer things about the graph, and now we're going to go the other way.
Correct.
We're giving you a picture, and you get to figure out what all those silly pieces mean.
Okay.
This will be fun. All right.
So, Last class we figured out that the C value was the limit to growth. So when
Okay.
we look at this picture, where does it look like the vertical or the upper bound is?
Horizontal asymptote.
Horizontal asymptote, the upper bound is.
Well, if I drew all over it, it'd be easier, but I think that said 500.
It does.
So that means that this C is 500.
It
So
is.
right away we have 500 over 1 plus a to the e to the negative bx.
Correct. And
God, that's
remember
a
in
lot
all
of
this
letters.
that E is a number.
Oh, okay.
So just remember that part.
So
Okay,
we really need to find an a and a b here.
we do. The next point they gave us is that the y-intercept is 5.
Okay, so that's where this would have been way down here.
Yes, and remember from last chapter, y-intercept happens where x is 0.
So we have this point 0, 5, and when we do this, it's going to allow us to solve for a.
It is.
So we're going to just plug in y equals 5.
Yep.
500 over 1 plus a times e to the negative b times 0. Well, what's b times 0?
0.
And what's e to the 0?
1.
So this is really 5. This whole mess makes 1.
It does.
So it's 500 over 1 plus a.
It is.
How do you solve that?
Multiply both sides by 1 plus a.
Good idea. That's what we did all year long, right? We just multiply everything by the common denominator, which is 1 plus a. And 1 plus a times 5 gives us, I'm going to go up here, 5 plus 5a.
Sure.
And 1 plus a times 500 over 1 plus a
500.
gives us 500. And any child of 5 can finish this problem,
Yeah,
correct?
it's 99.
Yeah, so a is 99.
Maybe not 5, but.
All right, well,
Okay.
15.
So now let's rewrite our equation with the things that we know. We know that the a is 99. You're going to need more.
We got y equals 500 over 1 plus 99 e to the negative bx.
Correct. And on the other slide, there was another order pair they gave us. It was 24, 135.
That's a nice round number.
Yeah.
So that means that we're going to take this and we're going to do the same thing because now that I know a, it'll let me find b.
It will.
All right, so we're going to plug in y equals 135. 500 over 1 plus 99.
Which is not 100 e to the negative bx. Please be careful.
E to the negative 24b. I just put the x first. Is that okay?
That's fine.
All right. All right. Now, how do you want to solve that?
Well, what I did to solve this is I graphed both sides. So 135 is your y1,
That's totally allowed.
and that other mess is y2.
I will tell you this. B in these problems tends to be a very small number.
It is.
So when you're trying to do this graphically and you have a big window, you're not going to see anything.
Right.
So you probably are going to want to set your x min and x max to be something like maybe -2 to 2 or -1 to 1. It's usually a number less than 1.
Okay.
So just so you know when it's coming up when you're doing this, that your window's going to have to be rather small to see this function. You could do this very similar to the last one, but it would involve, changing it into an exponential function, and it gets a little messier. So
It does.
the graphing thing is fine. Calculate the intersection. If you're having problems with this, please come talk to us. We'll run through it with you. We're not going to take the time for the video to do it. What does b equal?
B, you scribble some more, is 0.150. It's actually
What was that?
0.15000.
0.150.
000, and then some other number. I lost track.
So why am I writing all the zeros?
Please.
It's because you want me to. Here, you want me, can I color?
Sure.
I can make all kinds
Only
of pretty
if you write me a
pictures.
function, please.
I can write lots of pretty pictures.
Please, can I have a function? How about y equals
All right.
500 over 1 plus 99 e to the negative 0.15x. And that's that nice pretty red line picture that we saw. Beautiful.
Happy?
Yes.
All right.
You should put the pen down now. All right, so now to the fun part of lesson 3.6.
I've been demoted. All right, fun part. Why is it fun? Because I save money when I go to the car dealer with this, and if you ever plan on buying a car, it would justify spending $100. You might even want to show your parents how to use it.
Yep, I did it.
Okay? In fact, if your parents want to watch,
Go get them.
Go
Just
get 'em.
hit pause and go get them.
all right.
Okay, so what you need to use is something called the TMV solver. Okay, and this is an app that's built into your calculator. Okay,
It's not the TVM solver.
oh, maybe it is the TVM.
It's time value money.
Okay, it's TVM. Little typo there. The TVM solver.
All right.
Picky.
There's only one of them.
Okay, what it does is it solves for one variable when you have a whole bunch of given values for 4 or 5 remaining variables. Okay, so when we think of buying a car or anything where you're doing periodic payments, things like that, the amount of interest you get is based off how long that money is in there. It's called compound interest. Okay, and so this is a shortcut for all that mess.
Yeah, basically what you could do is, like I said, for buying a car, I think that's our first example, isn't it?
It is.
You could figure out your monthly payment based on what the price of the car is, or you could figure out, if you know your monthly payment, you could figure out how much car you could afford. Or
Right.
if you do like I do and you walk into the dealer, you figure out what that interest rate is they're charging you, and you tell them that's outrageous and go talk to somebody else.
Yeah.
So, just some thoughts and some things to think about. So here we go.
Actually, the first one is to go over what are all these variables. When you push the TVM button,
Hold on, don't push. Let's figure out where that is, by the way.
you have to push apps.
Let's go back to the main screen. Apps button.
Apps button.
Come on, you stupid thing. Is right there. The first thing on your thing is finance. If you have an
Finance.
83, there's probably nothing else unless you made one. All right. Press enter.
And the TVM
Time
solver.
value money.
I think I called it that for a whole year, so I got confused.
Okay.
It's going to show you all these variables. Okay? So make that go away, please.
Make it go away.
Yeah. Because I have it. It's right there.
Ooh, fancy you. Where'd the rest of it go?
I don't know. There you go. Okay, so it's going to give you an N, which is the number of compounding periods.
Or payments in
Or
case if
payments.
you're paying for a car.
I is going to be the interest rate. And the difference about the interest rate here is you don't convert it to a decimal. So
Right.
if it's 6.5, you just put in 6.5.
Just remember, it's in the calculator. It's foolproof. You don't have to know any math.
Yeah.
So don't even change the decimal to or percent to a decimal.
The present value of the account or the investment, which if you're just starting it would be
Zero.
Zero.
If you're borrowing or you're buying a car, it would be the price of the car.
correct. The payment, however much you're going to pay, the monthly payment or
And
semi-annual.
that's usually going to be
whatever.
negative because any money out of your pocket is negative. You have that written down there
I
too?
do,
You know,
somewhere.
I didn't know that for the longest time.
Okay, any money paid out is a negative number.
Yay.
Money out of your pocket goes negative. Okay. Future value of the account or investment. So if it's a car, you're paying it off.
Hopefully it's zero.
It's zero. If you're saving money,
Then
you might
want
want
it
to
to be
save
$1 million.
to a certain payments per year and compounding periods per year. We're always going to have those two things be equal.
That's helpful because
Okay.
the calculator automatically changes the second one when you type in the first one.
It does. And for the two examples we're going to do, we have one payment at an end and one at a beginning, but I think there's a direction on your worksheet of how to do that. Okay, so let's talk about Sal. He's going to have a retirement account. Okay, he's going to put $50 in at the end of each quarter. He's not really saving very much money, but it's better than shoving it in his mattress. Okay.
In this day and age, it'd probably be better off.
Okay, and the account earns 6.12 annual interest,
That's how
and he
you know
wants
this
to
is
retire
not a
in
realistic problem for today.
15 years. Shut up, you. How much money will be in his account at that time?
All right, so how many, N is the
N.
number of things he's going to do. I mean, the number of payments or the number of times that we're going to do something. So for 15 years, we're going to do this once a quarter, so
We
that's
are.
60.
And your calculator, again, is idiot-proof. You can just
can-
type
yeah.
in 4 times 15, and it'll convert it to 60 for you.
All right,
Okay, the interest rate is
6.12.
6.12. The present value of the account.
Hey, well, we got nothing in there.
We got nothing in there. The payment is...
Payment is going to be negative 50 because
thank you.
anything that's out of your pocket is going to be negative. That was from the previous screen.
We just said that, didn't we?
Yes, we did. And you even underlined it.
I was just trying to
but
make it line
even
up.
though you're putting money in the bank, the way the calculator works is it's money out of your pocket is always negative. All
Okay.
right, the future value is what we're going to solve for. And the payments per year is going to be the 4 times every year, which
4 times.
should automatically change
The
C/Y. to
Compounding,
4.
yeah. I'm not sure where the rest of that went. And notice it says that he's doing it at the end of each quarter.
So make sure end is highlighted at the bottom.
Now, the weird thing about the calculator is that you can only leave one thing blank. So make sure the very last thing you type in is the thing you want blank. Can
And
you
you-
make it this pretty for us?
I'm trying, but the machine's not cooperating.
The present value is 0. The payment was negative 50.
And you actually don't want to leave it completely blank. You want to have something in there, but you're
Yep.
going to just solve on top of it.
Correct. The
So
future value is
even
what we
0
don't
is
know, but
fine.
just leave it there.
But don't delete it. Now notice when I press enter here, it changes that to 4
And it was at the end of the quarter.
and highlights already in. So I'm going to go back up to future value and highlight it. And then how am I going to solve for it?
Alpha enter.
Alpha enter. Sorry.
All right. At the end of his 15 years, he will have saved a whopping
$4,859.24. Don't forget about that 24 cents.